Body drag at high Mach number. Excuse me. Body drag on high Mach numbers. All the data presented on this point are the nearly incompressible flows with Mach number as less than. So, to this point, we studied incompressible flow and their Mach number smaller than 3/10. Beyond this value, compressibility can be very important. We have change in the drag force as a function of Reynolds and the Mach number. As the stream Mach number increases at the subsonic value, if Mach, for example, greater than 3/10, that depends on the body's bluntness and thickness. The local velocity at some point near the body surface will become sonic. If Mach increases beyond, shock waves form, intensify and spread, raising surface pressure near the front of the body and therefore increasing the pressure drag. The effect can be dramatic with the coefficient drag increasing tenfold, and 70 years ago this sharp increase was called the sonic barrier. Implied that it could not be surrounded. Of course, it can be the rise in suddenly rise. It can be the rise in the drag coefficient is final, as supersonic bullets have proven for centuries. This figure shows the effect of Mach number on the drag coefficient of various body shapes tested in air. We see that compressibility affects blunt bodies earlier with the Mach equals to for the 4/10. Let me show the point for cylinder. For example, this point laminar shows also with these arrows here. And 6/10 for a sphere for cylinder. Critical Mach, right. For 6/10 for a sphere. And 7/10 for airfoils. And pointed above and pointed projectile. Also the Reynolds number has a large effect below Reynolds number, has a large effect below the critical Mach. In contrast, the effect of Reynolds number is small for airfoils. The effect of Reynolds number for airfoils, Reynolds effects is lower. And projectiles and is not shown in this picture. A general statement may divide Reynolds and Mach number effects as follows. Point 1. For the incompressible flows that we Reynolds number important, Mach number unimportant. And second, for Mach between 1 and both Reynolds and Mach number important. For the supersonic, Reynolds number unimportant, and Mach important, obvious from the velocity of the bodies. At supersonic speed, a broad bow shock wave forms in front of the body. Bow shock wave forms and the drag is mainly due to high shock-induced pressure on the front. Making the bow a sharp point can sharply reduce the drag also as shown, but does not eliminate the bow shock. The next chapters, especially chapter 9, gives a brief treatment of compressible flows. For more description, the next section in this chapter is biological drag reduction.